In the previous example, I told you x is -4, -3, -2 likewise. Sometimes without doing that, in the question paper, they will give you a range like this. Okay? A range like this. What it means was x is starting from -4 until 2. You have to consider all the in between whole numbers. Starting from x is -4 until it reach number 2, you have to consider all the whole values in between them. So in the inequality, we have an equal. So -4, -2, sorry, -3, -2, -1, 0, +1, +2. Until you reach +2 value, you have to write all the whole numbers. Thereafter, we can find their corresponding y coordinates. It's not compulsory. If you are having x is starting from -4, it is not compulsory to write until +4. Some students will think like that. Okay, starting from -4 until it reach +4, definitely we need to do. No, not exactly. Because according to their requirement in the question, they were given an inequality to show, okay, these are the values you have to consider. So we can limit our graph within that one. So here the graph name y equals to x star plus 2x minus 7. This is the graph name. Let's find the y coordinate for this case. When x is -4, in this formula you have to substitute x as -4 to find the y value. So y should be x is -4 star. While you are handling with negative numbers, it's better, no, definitely you should keep it inside the bracket. Plus 2 times of -4 minus 7. So -4 star means -4 into -4. 2 times of -4, it will become -8 minus 7. Here let's come. Negative into negative positive. 4 4 are 16. 16 minus 8 and 7 will become -15. 16 minus 15, it could be +1. It could be +1. Next, let's find when x is equals to -1. Sorry, yeah, -1 star. 2 times of -1 minus 7. So -1 into -1 plus 2 times of -1 is 2 minus 7. Negative into negative +1, it will become -9. So it is -8. So I have given you two values. Okay, how to find the values when x is these numbers. So I explained two examples. By using that, try to find other values. Thereafter, let's have a look. Try to do that by yourself. Thereafter, come to here. Now let's substitute x as -3. So -3 is 9 minus 6 minus 7. So it will become -4. Yes, -4. Then when x is -2 star, that is 4. -2 plus 2 is -4 minus 7, -7. And symmetrically here -7, it could be 1. So 4 and +1. These are the x and y values. Accordingly, we can plan our graph. In x-axis, the maximum value we need is +2. Minimum value is -4 to +2. In y-axis, minimum value -8, maximum value +1. Likewise, we can plan to plot our graph function. So in y-axis, maximum we need is +1. Okay, +1. So here I write +1. Yeah, so 0, -1, -2, -3, -4, -5, -6, -7, and -8. This is enough. Axis is -4 to 2. So -4, -3, -2, -1, 0, 1, and 2. This is enough. This is our x axis. Thereafter, we can mark our coordinates. When x is negative 4, y should be 1. Okay, negative 4 and 1. When x is negative 3, y should be negative 4. So here. When x is negative 2, y should be negative 7. Here. X is 0, y is, sorry, x is negative 1, y is 8. Yeah. X is 0, y is 7. X is 1, y is negative 4. So here. X is 2, y should be 1. Here. Okay. We have our coordinates. We can connect them by using a pencil. Don't use straight rulers. Okay, we have completed to draw a graph, a function. Okay, you can mark the coordinates and connect them. That will give you a negative curvature graph function. Okay, in the first question, minimum value of this function. Minimum value means graph is decreasing until here, until this point that is decreasing. At this point, suddenly that is changing its direction to moving upward. So this is the minimum point. So when y is equals to negative 8, y is equals to negative 8, this is the place when the function is holding there its minimum value. The coordinates of turning points, okay, points, plural form. In some graphs, we will have kind of this, okay, kind of this. Here there are two turning points. Look at here, coming downwards and changing its direction, going upward, changing its direction to move downward. So likewise, in those cases, we will have more than one turning point. But here only a turning point. So graph is coming downwards at this point. Suddenly it is changing its direction to move upwards. So coordinate would be 0, negative 8. This is the coordinate of the turning point. Okay, turning start here to here. This is the turning point. That's obvious. And thereafter, for the next question, the equation of axis of symmetry. Think logically. So when I split this graph through this line, okay, through here only, I can obtain a symmetrical graph. Okay, through here. This is the least point. Here also you can see this is the minimum point. Through minimum point, when you cut your graph, you can obtain the symmetrical two portions. So this one is a symmetrical one. This is symmetrical to this one. So when x is equals to negative 1, when x is equals to negative 1, so that when you draw a vertical line, that will give you the exact symmetry to the particular function, the pre-existing function. For this function, this would be our symmetrical line. We cannot draw a symmetrical line through this axis. Look at this. When you have like this, here we cannot obtain any symmetry. So that's why at the minimum point, to the minimum point, just draw a vertical line that is going through when x is equals to negative 1. So that would be the symmetry. Here I made a mistake. Sorry about it. It's not 0. Okay, it's not 0. The coordinates of turning point, this is our turning point of its coordinate. Its x value is negative 1, y value is negative 1, negative 8. So negative 1 comma negative 8 would be the coordinate of turning point. I'm really sorry about it because I have indicated it as 0 and negative 8. That's incorrect. Negative 1 and negative 8, that would be the coordinate of the um, turning point. And roots of this function. Okay, this is also not a difficult one. Roots means when this graph is intersected with y-axis. When this graph is intersected with our x-axis, it will produce 2 points. It will produce 2 points. These 2 points are called as roots of this function. Roots of this function at this exact point. Mostly that would be a decimal value. When a function is intersected with x-axis, that will produce some value, mostly two values. Okay, here and here. These are the intersection between our function and x-axis. So you can find the exact decimal points to produce it as roots of this function. That is mostly uh, x is equals to negative 3.9, somewhere 3.9 or 3.8, comma, and when x is in positive region also we have another intersection. When x is around positive 1.9 also you will have the exact roots. A root means function intersected with our x-axis. Okay. For the next one, the ranges, to find the ranges. Before starting to find the answer for the fifth question, I will try this question 6. For that sixth question, um, the values of x which y equals to negative 5. When y is equals to negative 5, what are the x values? That's our question. So what you have to do is, through y is equals to negative 5, you have to draw a straight line. By using a ruler, you have to draw a straight line when y is equal to negative 5. That will intersect with this graph at 2 points. At 2 points, it will be intersected with our function. You have to find their corresponding x coordinates. Their corresponding x coordinates. That would be answer. Okay, that would be the answer for our question. Somewhere here and somewhere here. You can draw that easily in your book. You can easily draw and find their corresponding x value. When y is equals to negative 5, what are the values for x? Through y is equals to negative 5, you have to produce a straight line that will be intersected with at 2 points in our curvature, in our function. You can find their corresponding x coordinates. That will give you the answer. It is somewhere negative x is negative 2.9 or 2.8. According to your picture, that will change with decimals. Okay, 2.8, 2.9, 2.7, like. But that does not exceed negative 3. That is important because negative 3 is here, negative 2 is here. In between negative 2 and negative 3, you have to get the precise value. Here also look at this 0, 1. When 1 is x is 1, y would be negative 4. Since our y is negative 5, that should be located in between 0 to 1. So negative 2.8 and x is equal to 0.8 or 0.9. At those places only, we will have y as negative 5 in our function. Then let's come to our last part. For that, you have to split this total graph into 4 quarters. So this quarter 1, and second quarter I will use another color, blue. Okay, this is our quarter 2. Quarters will be splitted according to their axis. Okay, starting from here to here, here to here, and here to here, here to here. That's how I am going to split the function. So here to here, okay, here to here. This is another portion, and last one would be here. We can analyze whether that is positive or negative, or positively increasing or negatively increasing. Likewise, we can analyze this function. First, the question is, mm, the range of values of x which the function is negative. When the function is negative means, in the previous explanation also I told you that this is our reference line x. Above this, the function is positive. Above this x-axis, the function is positive. Below this, the function is negative. So since our question is function is negative, you have to consider about this one. Below this x-axis, we have this amount of function. So starting from negative 3.9, negative 3.9 to moving here until 1.9, somewhere 1.9, in between when the value is, okay, the values for x are in between this region. Okay, in here the function is always negative. That's what you have to denote over here. Then function is positive, that means above the x-axis. So this region and this region, we cannot write the range in one answer, you have to write the ranges in two. So when x is less than 3.9, okay, in this region the values are less than negative 3.9. When x is less than negative 3.9, in left hand side the values are decreasing. So when x is less than 3.9, negative 3.9, and in those regions the function is positive. The function is positive. Another region also possible, suitable, above the x-axis. Look at this region. When x is, when x is exceeding 1.9, when x is greater than 1.9, okay, 2, 2.1, 2.2, 2.3, in those regions, the function is positive. Function is positive. For function is negative, you can write the answer in one interval. But for other one, since these are two separate ones, you cannot express them in an interval. You have to indicate two intervals for their separate characteristics. Then let's come to our next part. For that, decreasing positively. So first I will analyze them. Thereafter, let's come to this question. So for here, the function is positive 1, 0.5, 0. Function is decreasing. Here function is decreasing. Here also negative 1, negative 2, negative 3, negative 4, negative 5. Here also the function is decreasing in this region, in this quarter. I will, and here the function is going to increase. Negative 8, negative 7, negative 6, negative 5 until 0, that is in increasing manner. In this region function is increasing. Here also starting from 0, 1, 2, that is increasing. That is increasing. Then that is positive or negative. That's what we need to find here. Um, Above the x-axis, all the y values are positive. So this is positively decreasing region. Positively decreasing. Here look at this below the x-axis. The function means their respective y coordinates. Those are negative. So this region is negatively decreasing region. Here negatively increasing because this is below the x-axis, no, above the x-axis, positively increasing. Now we analyze whether that's positive or negative, increasing or decreasing. Then we can answer to the question. What are the questions? Decreasing positively. Decreasing positively. So look at this in this region, decreasing and positively in this region. So when x is here, when x is here, that means when x is less than negative 3.9. When x is less than negative 3.9, that means negative 3.1 and their lesser values negative 4, negative 4.1, negative 4.2, negative 4.3. In those regions, the function is decreasing. The function is decreasing. Likewise, we can write the answer as when x is less than 3.9, that would be the region for decreasing positively. Then next one, increasing positively. Let's come to that one. Increasing negatively. So increasing and negatively, that means this region. So here to here. So here we cannot write that one like this. So in between the interval, x is starting from 0 until it reaches 1.9, that is increase. Starting from 0 until 1.9, x is increasing positively. X is, when x is in this particular interval, that our function is increasing negative. So here to here, the orange color region, you can write, find their corresponding x region, 0 to 1.9. You can express that one in interval. This one looks little complex. Okay, as I think it looks little complex to you, don't confuse with it. It is really simple. Okay, look at this region. Positively increasing means, okay, here, okay. For the limitation only, we have plotted our graph until here. This graph is going until infinity. We cannot draw infinity in our paper, no, that's why we limited our graph with this until here. So when x is less than any values, than negative 3.9, that is positively decreasing. Positively decreasing. That's what you have to take as a conclusion from here.